Good day, everyone. Welcome back to BST African Electronics Surgery. So we received some job from another computer repair shop. We received this is an SSD. This is an SSD drive that came in for repair and data recovery. It's M2 M2 NVMe. And then we have another motherboard here, which I believe this looks like an HP motherboard that came in for repair, no power. We have another Acer laptop, which we don't know because the back cover is missing. The laptop is like this. So we have 3 items to repair. So what can we start with? Let's start with the motherboard. Let's start with the motherboard. This one. This is a motherboard for HP. So the motherboard looks like this. We have the switch. The switch is here. Charging port. We have this connector which is going to the USB. And the LED here. And that's all. No, we have heat sink, DDR3. RAM, BIOS battery socket, but the BIOS battery is missing. So let's see what this motherboard is doing without wasting time. We have the power supply set on 19 volts. I would love to know the amperage before I inject here. 3.2 amps, that's fine. So plug in the power supply. It's taking 3.2 amps, which is the max current, and the voltage dropped to 4.3 volts. That means we have a short to ground. And the resistance is like 0 ohms to ground. The main 19 volts power line is shorted by close to 0 ohms resistance. This is very, very low resistance to ground. So something is shorted. Oh, I think something is heating up here. Let's see under microscope what's going on here. Let's see what's going on here. We have the input section here. Oh, that's the BQ chip. The BQ chip is blown up. Huh? We have a blown up BQ chip. Huh? You see that chip? It's BQ25A. How this is possible? And that the chip which is getting hot. The fault is very obvious. We have a blown up BQ chip. Okay. But before taking out the BQ chip, let's check few things. The first MOSFET, drain source is beeping up. And comparing with ground, the input of the first MOSFET is not grounded. The output is not grounded. The input of the second is not. And the output of the second MOSFET is shorted to ground. And I'm sure it's because of that blown up BQ chip. And the first MOSFET source to gate is shorted. Source to drain is beeping up. So the first MOSFET is gone. We don't want to waste time. Let's jump straight to replace the first MOSFET. Let's go straight to the problem. This must be channel N MOSFET. Based on what I see here, the last digit is 6, which is an even number. So I explain how these MOSFETs are working. But to confirm that this MOSFET is gone for good, we can test this MOSFET. Let's check the MOSFET. We have this metal thing which is drain. Yeah, the MOSFET is shorted. No explanation there. Let me look for another MOSFET from board for space. What about here? I think we can take this one. Yeah, I think we can take this one. Let's take down this MOSFET. Oh, they are switching devices. Those are MOSFETs on the input section. We have first and second MOSFET and the current sensor. And from there, that the VCC point, the voltage is going everywhere. So we have to understand this. Oh, where is my MOSFET? My MOSFET. Good. Our MOSFET is now in place. Our next problem is the BQ chip. The BQ chip is exploded. And what is important on the BQ chip? We have the VCC pin, which is inputting 20 volts or 19 or whatever, 18 volts. And after that, we have pin number 6, that's the AC detect pin, which must be above 0.6 volts. What else? We have a regulator, linear regulator output pin on this BQ chip, which must be above 6 volts. And I believe on the output, we must be have a capacitor. So I'll check for the capacitor for short. Here's the input, because we have the resistor. Here's the output. You see this capacitor is 0, and I believe this is the linear regulator output, which is supposed to have around 6 volts. So let's take down the chip. Let's take down this chip. This is an obvious fault. We have a fault BQ chip, the charging controller, because the gates of those MOSFETs are going straight to this chip. Good. Here let's check out what is here. Okay. Pin number 1. Yeah, pin number 1. The track for pin number 1 is gone. So we have to fix that track. How we are going to do it, I don't know, but we have to fix that track in order to replace this chip nicely. We must have a track there. We must have a track there. So this can be tricky, but let's try to replace that pin number 1 track. So I need the flux here. Well, that pin is going to that capacitor. Okay. Now now we need to get rid of that jumper. Okay. Now what I want to do, another BQ chip, and we forget to check out the position. Oh, BQ25A. I guess that's the one. Yeah, I believe that's the one. So what I would do, I'll take down this big chip and we'll try to replace it. Now the tricky part is on the replacement side. Because that wire should not move. That wire should not move. Okay. All the tracks looks okay. Where is my soldering rake? Let's take away the solder. Now let's try to put this chip. What I would do, because here we don't need a lot of movement. Let's put more flux. Again. Now, I think we are done. I think we are done. What I want to do, I wanna get rid of this wire. Well, the wire is too long. So now, let's see if we still have a shorted main power rail, ground, why we still have a short? Why we still have a short? Anyone knows? Why we still have a short there? The main 19 volts power line is shorted. Maybe something else is shorting the main 19 volts power line. Because if we check on the BQ chip, here the short is gone. So let's see what's going on here. Let's see what's going on. And it's checking. We have another chip here. Which is faulty. This motherboard. We have this chip which is faulty. I don't know how this motherboard died. But trust me, we have so many faults on this motherboard. Something is not right here. So this chip is faulty. Oh, this motherboard. Where can I get one? Let me look for this chip. Or I can check out this chip and see. I believe this is the 3.3 and 5 volts regulator. It's also shorting the main 19 volts power line. Let's see. The chip is out. I want to test for short on the main 19 volts power line. And the short is gone. Okay. Check here. I'm checking from the current resistor to ground. The short is gone. So the question is where to get that chip. So let me look for this driver. So let's replace this chip. Let's replace this chip. Okay. Let's replace this chip. Okay. I think we have successfully replaced the chip, but we have a bridge there which we have to take out. And my soldering rig just disappeared. And I think we have successfully removed the bridge. because we don't want to short anything. Let's check for short again on the input section. Do we still have a shorted? And the short is gone. The short is gone. Now the good part is, do you have a working motherboard? So let's see. Let's see. Let's see now. Let's plug the power supply. Do we now have a working motherboard or not? Power supply plugged. And it's not going like, there's no voltage drop, which is a good sign. Now, let's check some voltages on the charging port. We have 19, but we don't have light. To my surprise, we don't have light. So this motherboard, output of the first MOSFET 0, current sensor 0. On the BQ chip, I want to check the V-in. 19 volts, pin number 6, AC detect pin 2.66. So the BQ chip is now working. The BQ chip is now a voltage. So why the first MOSFET is not outputting anything? You know what? This single chipboard motherboard can be a waste of time. Let's check on the last pin of the BIOS chip. We have a BIOS chip here. Pin number 1, 2, 3, 4. Diode. Pin number 1, 2, 3, 4. Pin number 4 is ground. Pin number 1, 2, 3, 4. Pin number 8. And pin number 8 is also beeping to ground. So I think I know the story. Because I don't want to waste time. What about coils? What the resistance do we have? Coil to ground. On this one, we have 86 ohms. Here, 1 ohm. Why we have 1 ohm here? This one, 86 here, 1 ohm. Okay. On this one, 1.1 ohm, 250 ohms. Okay. For the charging, 6 kilo ohms. But why here we have 1 ohm? Like 0 ohms. I know the processor is meant to work with a very low voltage. That means the resistance to ground is very low. But 1 ohm doesn't look good. Like 1 ohm. Let's see what is shorted on the last pin of the BIOS chip. What is taking the current? So I will lower the voltage. I need a thermal camera. I need a thermal camera. What I want to do, I want to supply 3 volts. 3 volts or even 1.8. 1.76 was safe. Maybe it's a 1.8 volts BIOS chip. And with 1.7 is taking 2.9 amps. And what is taking 2.9 amps is now 3 amps. What is taking that current? It's taking 3 amps. One side of the processor. Check what the processor is doing. You see? Maybe you can't see. You can't see, sorry. You see the other side of the processor? That is the processor. You see the other side of the processor? I take out the probe. There's no more heat anymore. I inject some power. This is a dirty processor. Huh? The processor is dead. So, if we check on the rest of the motherboard, what is here? How do I check the other side of the motherboard? Those are probes. The E.T.C chip is cold. So, I don't think I can do anything here. I'm sorry. I don't think I can do anything because this looks like it's died due to over voltage. The BQ chip was exploded. I replaced the BQ chip. The first MOSFET was also exploded. And after replacing the BQ chip and the first MOSFET, here the driver for 5 volts and 3.3 regulator was also shorted. Now, the last pin of the BIOS chip is taking, like, let's see the resistance to ground. How many ohms? Even if it's a 1.8 BIOS chip, like 1.75 ohms. The resistance is very low. And here we have a short. And what is taking this? It is the processor. So that shorted 3.3 volts. Probably what is shorted is the PCH inside the processor. Because pin number 8 is grounded, pin number 4 is grounded. Pin number 8, like 0 ohms. So yeah, We can't win every time. I will return this. This is the time for another motherboard. So, yeah, the repair attempt was unsuccessful. I don't get disappointed with such kind of jobs because it's common, especially on single chip motherboards. The processor is dying so easily. So like, subscribe, don't forget to turn on the notification bell for future updates. Also share our videos for beloved friends and relatives, and see you on the next one. Bye.